we're trying to be objective here, and this is intended to be some interactive session later on. I actually want your feedback. Just to check who saw my earlier presentation of those of Vesna. Okay, so you're all fairly familiar with subject. IPv4 is running out and IPv6 now. Disclaimer, although the logo from our sponsor is up there, I actually am on the payroll from Access for All. This does not necessarily express the company opinion. This is more about me. So, short agenda. I'll give some background, but I think we can skip on that one because you all know what's happening. Introduction on NAT. I think you're all fairly technical, I hope at least, so we can go over that very soon. Well, in the end, there's the open mic, and it would actually, the session is archived, and probably if you give some decent feedback, I will take that feedback, recompile it in a presentation, and for instance use that in a more provider community like RIPE or the IETF to actually show what you think. So this is your chance on actually giving some comment. Well, the background of this, IPv4 is running out. Somewhere between now, as in today, and April 2012 is this a close estimate. So 18 months. Well, this is a little graph made by Randy Bush earlier. This is what's supposed to have happened. You see the IPv4 pool running out. IPv6 deployment takes up somewhere when IPv4 will run out. The cost of IPv4 will increase because we can't actually print out new IP addresses, but there are enough, and under pressure everything becomes liquid. So to a certain extent, if you pay enough, somebody will sell you his IP address and find another way of connecting to the internet. Well, this is how it's supposed to be. V6 taking over from V4 very gradually and no problem whatsoever. Well, this is today's reality. IPv4 is running out much faster as anybody expected. While at the same time, IPv6 deployment is a lot less active. There's not that much done, you know. I've showed you before, I've got 300,000 customers, only 20 of them have IPv6 at the moment. It's not even a small percentage, it's really, really tiny. So what will happen is the cost of IPv4 will go up and V6 will stay behind. Now there's your problem. In fact, Jeff Houston, who is actually one of the guys actually trying to figure out when we run out, described it as the internet is going to hit a brick wall with the growth engines at full speed. This is our future. This is within 18 months, the internet, we will hit the wall. Now all of a sudden there are no IP addresses left, the internet stops growing. So what's the big problem? Extending the life of IPv4. It's about short-term reasoning for it. There's no serious IPv6 deployment. The internet keeps on growing. But also for the long term, it's not expected for V4 to disappear within a reasonable time frame. Expectations are 40, 50 years. You still have IPv4 services running around in the internet. And some way, some form, you will need to talk to those services. Whether you have IPv6 or not, you need to talk to those IPv4 services for 40 years. So how are we going to do that? Well, here we go. Network address translation. Hands if you know what it is, or hands if you don't know what it is. Well, okay, so you're aware, every DSL modem at home, everybody uses it. It's fairly simple. You just translate and you basically keep track of who's sending what by port number and putting the traffic back. Now, let's assume I have 200,000 customers connected to my network, and let's assume I can only afford 100,000 IP addresses. I say, let's assume I can afford, because in the end, IP addresses will be there, just you have to pay for it. So, well, I do the same thing in my provider network. I basically buy a big router, put it in front of it, give all my customers an RFC 1918 address, and on the outside, I have one address, and I actually have two customers sharing a single IP address. So you will be sharing the same IP address as your neighbor. This poses some very easy problems already. What about duplicate RFC 1918 addresses? Because if I'm going to use 10/8 in my network, obviously it's pretty hard if the customer is also using 10/8. That can get messy. So actually I'm going to tell the customer to not use 10/8 and because I want to do it. And for some other providers, 10/8 will only provide you with 16 million addresses. What happens if you're like Comcast and you have over 16 million users? Then all of a sudden you have duplicate addresses in your own network. So what are you going to do? Well, some guys at the IETF got smart and they call it dual stack light these days. What if we not only use the IPv4 address of the modem, but we use an IPv6 address? So yes, this involves rolling out IPv6, but only rolling out IPv6 in the edge of your network. The customer doesn't know it. The way it then works is that on the left you still have the IPv4 connection. Instead of the modem translating that source destination pair as a normal NAT, it would actually stick on an IPv6 header. And on the provider side, there's the carrier-grade NAT, as they call it, so the big NAT box in the provider's network, who will actually do the translation. The benefit of this is the CPE doesn't need to translate anything. And the great thing for your provider is that since you have IPv6 addresses, those addresses are unique. So you can use that IPv6 address to keep connections apart, and you don't have the problem of duplicate addresses in the customer space. Well, I already said this throws in a couple of issues. There are some other work being done, but it's roughly the same. In the end, you will be sharing addresses with your neighbor. So, well, what are the issues? Well, how many users per IP? Because obviously you have a limited set of ports. So how many users can you supply with one IP address? Well, Alan Durant did some work on IETF 74. He presented some things. And on average, you only have 5 connections per user, which with 60,000 port numbers would mean that you can easily put 10,000 customers behind one single IP. And you can sell all the other IPs off to your neighbor who wants to pay you good money for those IPv4 addresses. But if you're on the like Web2.0 Ajax site and those interactive sites like maps.google.com, you can easily jam up to like 200 connections. So there's still some things left. What about redundancy? Obviously you have that netbox in your network and it has to keep working, and if it reboots, it loses all state, all sessions. So all of a sudden you have 30,000 customers, the web browser, connection reset by peer. Who is peer and why is he messing with my network? Actually, we got that call, maybe once or twice. I want to talk to Peer because he keeps resetting my connection. Sorry, Peer is a sort of regular name here in the Lowlands. New CPE, DS Lite is nice, but for DS Lite you have to support IPv6 and DS Lite as itself as a protocol. So in fact you have to send the customer a new DSL modem or a new cable modem which supports it, costing a hell of a lot of money. Other small thingy, IP as an identity. Of course, it's still, people are getting smart, but there are still websites who actually use your IP to trace you. They place a cookie. If you come back, they know who you are. Unless you're sharing that IP address with your neighbor. And all of a sudden you can see which items your neighbor clicked on the website. Firewalls, what are you going to do with that, you know? Inbound connections. There's a lot of stuff to talk about. And, why not? Well, why should we do this? IPv4, NAT. Well, as I said, the internet needs to keep running, and we're running out of space, and we're running out of time. So, in the end, we need a solution. But how much will that solution cost? And how much time do we actually have to develop something? And as somebody described it, unity of purpose. In the end, you as an end user, me as a carrier, my equipment vendors, we all need to work together and all decide on the same way to go. Now, from an end user perspective, and that's why I'm here, you might think differently. From a carrier standpoint, my only job is to sell you connectivity to the internet, one way or another. In the end, I supply you with a connection. I think the big question is, what would you pay for a real IP address? And we can actually try that right now as part of that interactive session. As I said, the cost of IPv4 will run up. So let's assume that your basic entry-level internet connection at home, whether it's cable or DSL, comes with a private address. And who would like to, let's say, pay $2 a month extra to get a real IP address? Show your hands. Well, that's the whole room, so that ain't gonna work, because if you all pay $2, I get rich, but I still don't have enough IP addresses. So the price goes up, $5 a month. Who's there? It's still a lot of people, so $10 a month then. Yeah, now we're talking. About $10 a month, about 25% of you will have a real IP address, and the other ones can share an address, because they're not paying. So this is the way the mechanism is going to work if you're not careful. If you don't deploy IPv6, this is reality in 18 months. So back to the real topic, the dangers and merits. Yeah, because net. Well, you all been running nets at home. You know that there's a lot of fuss and you create certain problems. Like, for instance, incoming traffic. You know that I already said it in my earlier talk, and Vesna touched the subject as well. Currently, net acts as an implicit firewall. You don't get any incoming connections, unless you do some port forwarding. But what about if your provider is running that net for you? That provider will drop incoming connections, because how on earth will the provider know if he gets an incoming connection to a certain IP address, for which user that is? So, wave goodbye to your own mail server and web server running in your cupboard at home. Forget about it. So you can no longer run services. Peer-to-peer maybe becomes quite difficult. That's why I said, too bad the Brian guys are on the other side defending themselves. Because they would like it, you know? The end of file sharing. Oh, good. So that's why there's also stuff called merit. Denial of services. I have that big net box, and that can only support X amount of connections. X amount of connections per IP, but it also has limits on memory, CPU power. What if some customer starts port scanning? What if I all of a sudden have a huge virus outbreak, and all those virus PCs are building outside connections? That netbox might easily get overloaded and actually like reboot, and nobody has a connection. Small other danger of all traffic passing at one box. Now I'm sure as hell that those guys in the other room would like that, because they have one easy box. It's a sitting duck. You sit there, oh yeah, he's downloading this movie. Oh yeah, he's uploading that. And there you go. It's fairly easy to sniff on. And maybe some people use it for good thing and catch terrorists or whatever, or catch child abuser. But think about it. All your traffic is at one box. And again, for the more evil persons, it's also easy to take out. Take out that one box and take out the whole provider. That's a danger. Think about it. Well, what about application? I think, are there any programmers, application developers in the room? Yeah, we've got a few. Well, you probably are aware that if you have to pass NAT, you have to be careful. Because, for instance, SIP, but also FTP, you put IP addresses somewhere in the protocol other than the normal header. So your net has to be application aware. It actually has to track down those addresses, and when it does the header translation, also translate into the contents of your packet. Now, what about if those big box sits in front of millions and millions of users, and you want to release your own application? Skype, for instance. How would they handle that? If you want to release Skype 2, you have to talk to those providers who are running those NATs to get those NATs to pass your protocol. And, well, you have to talk to providers, but you more likely also need to talk to those vendors of those NATs. You have to talk to the Cisco's, the Junipers, to the world, about getting those nets fixed. before you can relaunch a new application. So it becomes fairly difficult to make a bug. It's really, there's no way around it. You can't easily release something, and if it's not taking up, abandon it, because you're talking about process of months getting those things done, maybe years, and a lot of money. But there's another danger. So, and that's actually where you come in, because as a provider, I'm actually selling your connection. You're paying my salary. Well, if you're an XSROL customer, you really are, but assume I'm just your generic provider. You're paying my salary. Your wish is my command. So what do you think? Is it a good thing? Is it a bad thing? Tell me, and I will take it up and bring it up to other providers about what's happening, and maybe the IETF. If you do comment, please state your name and affiliation. If you are all about privacy, don't do that. But please tell me which hat you're wearing. Are you wearing a hat from an end-user perspective, a carrier, or an application developer? So it's up to you. What do you think? It's a good thing, Ned? Bad? Please use the microphone. And
okay, so by night I'm actually a RIPE member as well. By day I'm a security researcher. I own an ISP on the side. It's the biggest change to the way the internet operates that we're likely to see in the next 5-10 years. Yeah. And it's one that I don't think we'll go back from. If this goes through, we'll essentially become consumers. And we won't be able to publish, which is exactly what the media companies across the way want. It's exactly what the big American telcos want, mostly because they're owned by the big media companies. Yeah. It needs to be stopped.
Yeah, but how do we stop it?
How do we stop?
Kill a couple of billion internet users? Or go IPv6?
Well, I guess one of the questions is why are IETF even looking at standardising this? Well, I've looked at the proposals that are being put forward. Why are IETF even taking this route? If IPv6 is apparently part of this solution anyway, because of the size of some of the ISPs. Why aren't the IETF taking a better lead in driving IPv6 forwards? And we have IPv6 natively. We don't have it at our edges because vendors aren't doing it.
There's also that point, because, of course, you can build your network completely IPv6 capable, but if somebody else doesn't, and that's why I think it's dangerous, is, for instance, if Comcast decides to go all net, you're screwed anyway. Whether you build your own network completely dual stack and you've got V6 and you've got enough V4 to last you a lifetime, still, if one of those big guys screws it up, and like you said, we're going back to the OC layer, you know?
Should we not be asking RIPE to mandate IPv6 across all of the carriers that are RIPE members? RIPE are big enough to punch some weight.
Yeah,
and if we're RIPE members, surely RIPE at some stage should be beholden to the interests of its members. And if those interests are only showed up by the side that want carrier grade NAT, then that's what will happen. If those that don't want it,
Bradley Freeman, private citizen, end user hat. I think using carrier grade NAT more and more with IPv4 will just encourage and put off real IPv6 adoption, and it might be a better solution to allow everyone to have their own IPv6 address native and then use some tunneling methods toward IPv4, and if they do need a dedicated IPv4 address for things like P2P, then they can pay to dual stack.
I made a small omission, but in fact Cisco is one of the vendors who is actually promoting carrier grade NAT, and I can only guess why they are actually promoting this, probably because they want to sell it. And it's much easier to sell a new box than actually tell people to just flip the switch and turn on IPv6 on their Cisco's, just buy a new one. But Cisco actually now states that whatever carrier grade NAT you are deploying, you have to also make sure that you deploy IPv6 natively to maintain the end-to-end connectivity principle of the internet. So there's some light at the end of the tunnel, but whether or not people will listen to it, that's something completely different.
Cheers. I love that.
I think we all need IPv6, and the financial guys have the solution to the problem. The SWIFT network has also protocol changes.
Yeah.
And they say, well, if you want to stick to the old version, you have to pay extra. So every bank that has to pay extra they are suddenly in a hurry to
Obviously,
switch to the new protocol.
money is the thing, but
Yeah.
as I tested, there's only like 25% of the people who actually want to pay for a real address here in the room. In this room, yeah.
Yes, but I think you have to ask at corporate level,
Yeah.
because they are the guys who are steering this into one direction and not at the consumer level.
Yeah, and on one side you're right. If big corporations involves a lot of money, but think about what happens if like a million end users in your network vote with their feet and go to your opponent or your competitor. There's also a lot of money involved. The consumer market is big enough, but the only thing is the consumer market needs to be aware of this problem, and currently they aren't. Basically, the regular Joe average internet user isn't aware that the internet is getting full. They don't know what's coming. And one of the reasons we're up here, and one of the reasons that we're trying to get into the newspapers, is to actually make people aware of this problem, and make people aware that if you don't start phoning your operator, your telco, to ask for IPv6, they're not likely to roll out IPv6, and in the end you get stuck in this situation. I think that's the main thing.
Thank you very much.
My name is Andre, and I'm currently having the end-user hat on. And I think it's just the telcos who are the big carriers as well who are interested in carrier-grade NAT, right?
Yeah.
Who else should be interested? Okay, maybe also the vendors, but
Yeah, but as I can explain to that as being part of a big telco. Actually, we want to make extra money. We want to sell extra connections, and we've got basically the whole of the Netherlands has DSL now at home, or fiber, or at least broadband connectivity. But not everybody is carrying around an IP phone yet. But we are still pushing on mobile applications as well. You, as an end user, are taking up more and more IP addresses. And if I want to sell you, for instance, your second BlackBerry, I have to get an IP address to connect you to. And I think that's the main thing.
well, now looking at the mobile operators, they are already doing the carrier NAT. I mean, they are handling, at least in Germany, most of them are doing it. All four of them, they're giving you RFC 1918 addresses.
It differs, but you get more and more real internet devices as a mobile, and also when you start doing push services from outside of the telco network, you really have to the device needs to have a publicly routable address.
I know how it works, but the reality is different. Then they're using some different access points and using some VPNs in the end, and all that stuff, again with private IP addresses.
But yeah, in the end, why are the telcos and the large guys pushing around carrier-grade NAT? Is because they want to keep on selling stuff after April 2012, and the only way to do that is carrier-grade NAT, apparently.
I'm Volkert, I'm an end user. I was thinking, wouldn't it be possible to use protocols like SOX and UPnP so that clients can register on a central server what outbound and inbound port numbers they need? So then it's just a matter of a large pool of real addresses. Yeah,
for some stuff you can do that. For instance, for peer-to-peer and stuff it would work. But if you and your neighbor are both running a mail server and that both needs to open up port 25.
Yeah. But for that, then you wouldn't have just one IP address for multiple persons, but a pool of real IP addresses for.
In the end, it's all not everybody's running a mail server, especially not if you're like in the end user market and you've got 1 million end users. So then you probably get away with it. But and for those guys who want to run services, I think, wearing my evil corporate hat, that I'm better off selling you a real IP address.
Okay.
Hello, I'm Frans, wearing a big telco hat. You told in your earlier talk also about legislation you were imposed to make addresses of customers public available to law enforcement. How do you think that will impact the do or don'ts of carrier-grade NAT? Will it prevent it from being used?
Yeah, obviously it will be affected because as a flag like IP as an identity is gone. But on the other hand, I've got all those traffic nicely passing to one box. So I guess that in the end, legislation will follow. You know, in the end, it's a matter, and I'm also involved in discussions about legislation a bit. And yesterday, my colleague Scott was up, and he's really up into his neck into it. What actually happens in the Netherlands, but also in other countries, it's not much discussion whether or not stuff is useful. If they know you've got a box that's actually passing all that traffic and translating it, you're most likely are going to get the warrant because somebody will want that traffic, whether it can actually help them or not. You have the technology, they want access to it. That's the way it works. So if you start up carrier grade NAT, you're likely to face within like a year or 2 years, you're facing legislation to data retention, lawful interception on that box.
So it will just be an awful lot of questions coming from the police you have to process.
Yeah. Yeah, because the first time the police shows up, like, yeah, we want you, there's some fraud being done from this IP address. Can you tell us which user it is? Well, any of these 200. Then the next
just
thing.
dispatch to each
about an hour later, they will subpoena all your log files to actually find out who of the 200 it is. So legislation will adopt. I think that's the main, that's the point here.
Yeah, I would like to address the question before the last one. Here it applies what you already actually said before. Pretty much if you open 500 connections per user, suddenly you run out of ports. And this is outbound. What you said inbound, if some whatever virus or software starts opening ports, suddenly you just run out of inbound ports within seconds. Or if a computer wants to open like 1,000 ports, you have to start limiting a possible number of open ports. Things like that.
Other thing is timeout. How if you have a connection and I don't see traffic flowing, how long do I keep state? How long do I actually establish those sessions?
Yeah, and coming back to the last question, actually, I think I'm not 100% sure, but I think in Germany the data retention laws go into the direction that you have to actually log data.
Yeah, data retention is based on European law. So in the end, Germany, the only thing that differs is the amount of time you need to keep the log files.
Yeah, but in the end, it will turn out that you have to log each and every TCP connection and UDP packet and whatever.
Yeah, that's most likely.
Good luck buying that much of storage.
Yeah.
Don't we have the one box problem already? I mean, currently we're terminating the DSL sessions on backbone routers. I mean, it's already one box, and you can tap there.
Yeah, but the backbone router only looks at the address, forwards the packet, and basically forgets about it. Again, if you are as you're actually translating it, you have to cater for return packets to come back. So you actually have to establish a session because you know who sent you the packet, translate it. So
okay, I don't know how your network works exactly, but at least in Germany we have basically PPP over Ethernet, and you're having a tunnel terminating at this box, and so it's kind of a translation between the tunnel and the outside world already.
Yeah, whether or not you can call it, you could, with a broad view, you can call that translation, but it's more or less encapsulation, decapsulation of packets.
Of course, but I mean, you already have this one box in your. I mean, it might be two boxes or how many ever you're operating in your network. Yeah. But it's a very little number.
But the one thing that currently is happening that because I still have a public address tied to an end user, they're not actually interested in those log files because they can always, if they have the IP address, they can always find out who you are. But the moment I start translating, they no longer can find out who you are just by simply looking at the IP address, and I have to find out for them. So
Okay, yeah, yeah.
I actually get to wear a police hat and do some troubleshooting or prosecuting.
As you said in your speech, peer-to-peer file sharing will effectively be prevented by carrier-grade NAT. Does that mean, yesterday a speaker told us that about 50% of all internet users use peer-to-peer file sharing.
Yeah.
So I think your chances are pretty good that much more than the people who raise their hands will pay money for a real IP address to prevent carrier-grade NAT.
Yeah. But in the end, if we, like I said, if we all pay extra money,
which means that
Which
there's
means that
just no other option.
in the
than
end,
native IP addresses.
a real IP address becomes a luxury only for those who can afford it.
Yes.
And what about Africa coming online in the next couple of years? Actually, the first cable is live, and I already saw postings from Kenya like, yeah, we're switching over from satellite to fiber. Expect some traffic growth, and traffic growth means that the prices go down, and if prices go down, all of a sudden lots and lots more people can get internet access there. And how they're going to do that, as Vesna told you, there's that /8, and every NIC gets a /8, and now we're talking about building a company in Nigeria because we can get all the IP addresses we want. But if all of a sudden Africa is online, that /8 is gone as well. So maybe put whole of Africa behind net, and we can keep on using it. Oh, all right, we've got one vendor. So anything else? I think it's quite useful to have this kind of discussion and actually flag this problem. And now you are aware, and I would say like tell the rest, you know, and phone up your provider and tell them to start doing IPv6 and tell them you don't want to get stuck behind the net.
Hello, my name is Thomas.
Yeah.
I have the idea because NAT is evil, we all know it. And even if we translate 6 to 4, if the end user has IPv6 and wants to go to the rest of the internet, that would be a chance, but it's not the solution. In my opinion, we need a policy change, perhaps in the context of RIPE, perhaps as a measurement at the European Union in that form that we say there's an extra fee to be paid for everyone who gives only IPv4 access, and if he gives those, okay, it's
Taxing it, yeah.
And from the income of the extra fee from IPv4, one could deploy the IPv6 connectivity. Thus, they get the money the others would pay.
And basically, there's a couple of things we hate in the internet industry, and those guys are on the other side, and legislation. And what we actually did 2 years ago was, as a community sourced by RIPE, as the internet community actually put out a statement telling the government that no worries should be about the IPv4 runout because we will sort it ourselves. And you're actually now suggesting the other one. And yeah, one of the big dangers is, and that's basically one of the big dangers of not running IPv6, is that some government will get nervous and will decide for you whether or not to do it. And you might as well have a government saying, oh, well, put all your users behind net. Equal opportunity. In the end, IP addresses will cost money. And if from a historic perspective, I got a shitload of IP addresses. We were there in 1993. We've got enough. In the end, it's also a matter of anti-competition. If I got IP addresses and you don't, I'm already having a head start. So if you want to fund a new company, you have to get IP addresses and you have to pay for them. So yeah, you're likely, whatever happens, if we run out of IPv4, there is a little chance that governments will get involved and you will get anti-competition laws stating that you should share your IP addresses. Or maybe all of a sudden somebody decides that addresses should be portable. Whether we decide that it's provider aggregatable or not, I've seen governments do stupid things. Usually they don't know jack shit what's happening. Sorry for my language. And they just, oh well, they just invent the world. So, yeah, good idea, tax it, yeah, well, yeah. But in the end, still, if we start putting tax on IPv4, then again, it's a matter of whoever makes the most money, whoever gets the IP address.
Well, I think it should be made more attractive, and this thought was for end users and ESP. But I also think about mobile zip phone or so. It's unacceptable that a modern device you buy has only IPv4 access. It's not an investment for the future if I buy this, such a device. And perhaps one have to go the legislative way.
In the end,
that's my opinion.
In the end, it's you. Yeah, sure. But yeah, I think in the end, it's you guys and it's me, myself. We're spending the money, and we should talk to our vendors that we only want to spend money on stuff that's future-proof. And they will follow. They will always follow the money. Thanks. Anything else? Up?
Maybe I have another idea. New applications. Maybe
still wearing your telco hat?
Still have the telco hat and a little bit of the application programmer's hat now. And the bold statement was, let's make Twitter die on nuts. So Twitter cannot pass on NAT, and think about that. It's like if you build new applications, either build it so that if the net is involved, it will quickly eat away all the resources, or it doesn't work with a NAT.
Yeah.
Sorry, I have to bust in here. This has been done before. SIP was designed to break on NAT, and that has hindered its deployment widely, and that is why Skype is so great and has so many users, isn't it? If you try to build applications that intentionally break, well, someone will step in and make one that doesn't.
Yeah, but that's the problem. Skype was built when IPv6 was already available. Technically.
Yeah, but technically the whole internets were more or less built when IPv6 was available, because I think the first attempt of IPv6, first standard, dates back to 1992. And in 1992 the internet was like this big, no? We were out there and we were the only users. Those millions out there didn't even know what a computer was, let alone that those things can talk to each other. Maybe that was the point where we should have done something with IPv6. Well, I guess if that's up. Colin? Yeah, cool. We've still got time left, 20 minutes. So.
Evil hacker hat on again. Not again. But I don't know whether it's possible. Is it possible to rate limit carrier grade NAT per end user?
Break carrier grade net per end user. Yeah, depends on, I think it's implementation defined, and well, people are thinking about it, but they haven't seen any real life implementations yet.
Okay.
So, yeah, possibly. If there's some like quota, I think most likely is from the inside. You can actually saturate, like we said, there's probably going to be some limit on the number of connections per user. And I think in the end, if you're the inside, you can probably also use your neighbor's quota and actually starve that out, spoofing packets. If you spoof packets from the IP address of your neighbor, then the connections will show up on your neighbor's account. So you're likely to starve his stuff out. So yeah, it's breakable. Of course, we're hackers. We can break anything. Rate limit? Yeah, possibly, yeah. But I think, implementation defined. I haven't seen any real live examples yet. We still have IP addresses left. So if that's it, then thanks for being here. Peter? Oh yeah, Peter van Eyck. Well, for those interested in IPv6, Peter asked me, tomorrow 12 o'clock in Bike Shed Red, there's an IPv6 workshop. So go there. I'll be there around as well if I wake up early enough. Thanks for being here. I think this is the end of the IPv6 track. Enjoy the rest of the festival. Go and have fun. Sun is shining. It's wonderful weather. Thank you.